Today we're covering the second part of section P5, which is multiplying and dividing rational expressions. So we need to remember how we multiply fractions. So it says when multiplying fractions, we multiply straight across. Right, so that's all we need to remember. So we're going to combine toward the beginning of what we did with multiplying fractions and what we were doing with rational expressions. So as you can see here, this looks to be almost like a mess. We have a whole bunch of trinomial terms that we see can be factored, and we're multiplying them. But don't worry, we're not going to multiply straight across yet. We're going to factor both numerators, both denominators, see if there's any like terms that we can eliminate, and then simplify as much as possible. So we're going to go ahead and get started. We're going to keep our work all nice and neat. So another good thing about Notability is we have all these different colors. So I'm going to start with 2x squared plus x minus 6, and we are going to factor this. So I need two numbers that add together to give me 1, but when I multiply them, I get negative 12. So my factors are 4 and 3, with 3 being the negative. So now I'll do California method. So I'm going to do 2x over 4 and 2x over negative 3. So my first fraction reduces to x over 2. My second fraction doesn't reduce at all. So I get x plus 2 times 2x minus 3. Okay, and that's what this one reduces to. 1 done, 3 to go. Highlight it in that color, that way we know that, right? That one's purple. Next one, we'll do the denominator in this pink. So the next one is x squared plus 4x minus 5. Again, we have to factor this, so I need two numbers that add to give me 4, but when I multiply them, I get a negative 5. So we have a positive 5 and a negative 1. So this one, the leading coefficient is just 1, so we can go straight to x plus 5 times x minus 1. All right, second one's done. Numerator on our second fraction. So this one is x cubed minus 3x squared plus 2x. So the first thing I see is I can factor out an x. Then I'm left with x squared minus 3x plus 2. That x outside is just going to follow us along. So I'm going to factor what's inside my parentheses like normal. So I need two numbers that add to give me negative 3, but when I multiply them I get 2. That's going to be 2 and 1, and they're both going to be negative. So again, this leading coefficient here is just 1. Don't forget the x outside. Then I have x minus 2 times x minus 1. All right, and the last one, do blue. Well, this one's only a binomial, so this one shouldn't be too bad. And I will say not all of them will be trinomials. So this is 4x squared minus 6x. So I can factor out the GCF of 2x, and I'm left with 2x minus 3. And that one's all finished. So now I'm going to put all these together where they belong. So I'm going to do the numerator, x plus 2 all over, times 2x minus 3 all over x plus 5 times x minus 1 times x minus 2 times the quantity x minus 1 all over 2x times the quantity 2x minus 3. All right, so from here, we can, or could, write this all as one fraction if we wanted to, but we can also just start to simplify from here. So I see a 2x minus 3 in the numerator, a 2x minus 3 in the denominator. So those are gone. I see an x minus 1 in the numerator and an x minus 1 in the denominator. I also see, and this might be a little more tricky to see, an x here and an x here. So they're gone. So I'm going to write what all I'm left with, just to make sure. So I have an x plus 2 in the numerator times an x minus 2. Denominator, I have a 2. Then I have an x plus 5. Now remember, we canceled out 3 different things. So I have to now say, all right, x cannot equal. The first thing, remember we said each of them equals to 0. So I had an x I canceled, so that equals 0. That one's done. Then I canceled an x minus 1. So if I solve that, x cannot equal 1. And then I had a 2x minus 3. If I solve that, so those are the 3 values that cannot equal 0. Or that cannot equal x, sorry. So x can equal 0, it can equal 1, and it can equal 3 over 2 or 1.5. So this would be my final answer. Again, you could also write down that x does not have to equal, or x cannot equal -5, but that is our implied domain since we can still see that in the denominator, but it is not wrong to write. All right, you can see that if we were to do that your turn, and I'll write the answer down in case you want to go back and try it, that they're not all trinomials, so it's not too bad. So this answer should give you -8/5 with x not being able to equal -3 and +4. So if you want to try that one, that right there is the answer for you to double check. It's crazy, it looks like a whole lot of things cancel there. All right, the next part is division. So this division, I will tell you there is one step, and then it's the exact same thing that we just did. Because if you remember, when we divide fractions, we actually multiply by the reciprocal. So that's what I'm going to do. I'm going to rewrite this. So I'm going to have x cubed minus 8. And as soon as I see that, I am thinking of those differences we had with the u and the v, because that's going to come in handy. So I keep my first fraction the same. So here I'm keeping it. I switch division to multiplication. And then I flip the next fraction. In better terms, we multiply by the reciprocal. So my x cubed plus 8 is now in the numerator. And my x squared plus 2x plus 4 is now in the denominator. So my numerator here. I'll give it pink. Whoops. Okay. That is, and if I can scroll back fast enough, just to refresh your memory. Here it is. We are going to have both of these, the sum and the difference of 2 cubes. Okay, so don't forget that. We also are going to have the difference of squares, but usually people are okay with that. And then we have a regular trinomial. Okay. So don't forget those 2 things there. It's what I'm going to be working with to finish this problem. Okay, so this right here is the difference of cubes. So for that one, if u, I guess I should write this out. U is going to be x. V is going to be 2 because I took the cubed root of both of those to get u and v. Okay, so that numerator is going to look like x minus 2 times x squared plus 2x plus 4. Okay, that's just using that whole u and v. The denominator, let me get a slightly lighter color. I keep doing that. This is difference of squares, which a lot of you are more comfortable with. So that is going to be x plus 2 times x minus 2. Multiplied by this next numerator. I'll just write it up here. The u is going to be x. The v again is going to be 2. And it's going to be very similar to what I wrote in pink, except our addition and subtraction signs are in different places. So this one is going to be x plus 2 times x squared minus 2x plus 4. So remember those addition subtraction signs just change. And now for this last one, I noticed something, but we're going to go ahead and try it for this denominator. I need two numbers to add to give me 2, but when I multiply them, I get 4. Well, my only factors of 4 are 1 and 4 and 2 and 2. And there's no way that I can add any of those to get a combination of 2. So that means that trinomial is unfactorable. So I'm just leaving it as x squared plus 2x plus 4. Okay. So now that everything is completely factored, let's go through and see what can cancel. Oh, here's an x minus 2 and x minus 2. X plus 2, x plus 2. Look at this whole thing. Those two are exactly the same, so they're going to cancel that whole big trinomial. Now remember that trinomial is unfactorable. We could go through, do quadratic formula to find the values, so it looks like everything canceled except for my x squared minus 2x plus 4. Now we do need to remember that x cannot equal positive or negative 2. I'm going to let that go for now. In the future, once we get into this a little bit, maybe on one of the other lessons, once we refresh our memory on quadratic formula, because we are going to do that, we would use quadratic formula to find out what values of x would also make that denominator 0. Okay, for now we'll go with this. Maybe I can make a second video in case you would like to see how to do that. Or remind me whenever we're back in school that I can go over quadratic formula with you guys on that. All right, and the last your turn again, I will write the answer down for you. That way if you want to practice it, see if you're doing it right, you end up getting 1/3 and x cannot equal positive or negative 7.